Okay, so in this part, as we said, there was a problem there in the previous state table was that whenever the second coin was there, you see that it was transitioning to the state 0, right? Directly. It was not staying back there. So that means there was nothing separate for pouring. The pouring was happening as soon as you were putting the second coin, right? And that is what you want to remove from this machine because it was basically burning somebody's hand, or it could spill the chai because it's happening too fast. So the user want to have a control. That's why there's a second input. So X was there anyway for the coin, right? And there is another input which you have introduced is the pouring button, right? So that is which pours the chai. So that is the pouring. And then you see that both, when you're putting, both are not 1 1. So 1 1 uh, is invalid, right? For this. Both are not one at the same time, never. Because you are either putting the coin or you're pouring, right? That is the thing which you see. So then in this, if I were to translate this into the state transition, now first thing I see is there are three states because now when I go from initial case, which is my 0 or S0, right, where this is my initial. Then I put in 1 rupee coin. I go to some state, which is what I call S or the 10 rupee coin. Then now, because I'm waiting in the second state for the P to be enabling, uh, then there is a third stage which has to be there when I put in the another node. That means this is happening when X is 1, right? This is happening when X is 1, right? X is 1 and P is 0, right? Right? Because P, if P was 1 also, that case would never happen, right? So that's why it is this thing. But when what happens is after you are in state 2 and you press P, then you can come and pour the thing. So then what happens is that X is 0 because there's no coin which is put in, just that you press pour, and then you see that your output, whatever your output, which is Y, which is the pouring, this becomes small, right? Here this is 0, Y is 0. Here also Y is 0. Okay. So these are the few states which we have written. What about the other states? Because now if you see your state table, may look like something like you have X, you have P, and then you have, because you have three states, you need to at least use 2 bits. So that means you will use 0 0 0 1 and 1 0, right? So that means states means that these are the states which are described by at least 2 bits. So that means two flip-flops which we need, two DFF we needs, right? So two DFF means then we need two states of those DFF, which is Q1 and Q0, right? And then whatever are D1 and D0 we can directly write because that would be the next step anyway, right? Because we know D1 is anyway Q1 T plus 1, right? That is the D1 should be. Similarly, we can write that D0 is equal to Q0 T plus 1. Because whatever the next state you want it to be, it has to be the D, right? Then only it can be enabled. So we can directly write like that. But we see the now there are other inputs which are needed. 1 1 is not there, but what about 0 1? So only 1 0 is happening. So the other two inputs for which you have X is equal to X and P basically are 0 0 and 0 1. You see Y is 0, right? Nothing is happening. It's in the state, no nothing, no business. Similarly here, X and P 0 0 0 1. You see you remain in the state. Here you see what are the, you have to be careful because at 0 1 you see that it is going out. So here XP, if it is 0 0 or it is 1 0, right? Even if you put extra coin, it goes inside and it stays in the state, right? Y equal to 0. So that is how you can see that your state diagram now is kind of complete. and from there one can now build the state table. So state table, if you go, you have to, yeah, you can go by the same logic, just highlight all the states, right? 0 0 0 1 0 0 0 1 1, then 0 1 0 0 0 1 1 0, right? Or 0 uh, 0 1, right? And then 0 1 1 0 1 0 0 0. Still, there are many entries left, right? So we can continue that also. Uh, so the idea is that if you are little, you can just copy this table and make it twice. That is another way of doing this, because anyway, this is going to be right. Uh, yeah, so you can just copy this. Sorry, okay, I copied the whole thing. Just need to copy this bottom part, right? And suppose you can just copy it here, the other part here, right? Mm, yeah, I mean, I can just write 1 0 0 1. Then again, the same thing will start, right? The next part. So these are 16 entries should be there. 1, 2, 3, 4, 5, 6, 7, 8. 8 entries still here, and then you go other entries. I can just do in this, right? Then you see 1 0 1 0, right? 1 0 1 1, right? 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1, right? So 50 16 entries. Um, so then we see that we need to just fill up this table. Now looking at the state transition. So you see that when you are now, you just look at the states, right? So you are in the 0 0 state. If you are in 0 0 state for when x and p are both 1, so that is mm, yeah, let's just see first 0 0. That is easier. Let's see first the four entries. When you x and p are both 0 0, right? What is the state you should be in if you are in one of the states? So you see, if you are in 0 0 state, if they are both 0, you are in 0 states, right? So this will be 0 0 state. You remain in that state, right? And y, if you want to draw, you can draw also y is 0. Same way, you go on, you say, okay, if I am in 0 1 state, 0 1 state also, you remain in that state. You don't change the state, right? So you are, both are 0 0 like this. So you see here, 0 0 is there. So you remain in this state, 0 1 state. Again, y is 0. Same way, if you are in 1 0 state, which is this state, you see 0 0, you remain in this state again, which is 1 0, right? And then y remains 0. Now you are in 1 1. If you are in 1 1, 1 1 is not there. So everything is X because it's an invalid state. It is not existing, right? Um, 0 1. Now let's look at that when the input is 0 1, right? Which is still here. Right? So 0 1 0, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. I think 1 is missing. 0 1 1 1 is missing. 0 1 1 1. Okay. So they were, so 0 1 has four states, right? So again, the 1 1 is XX, right, which we know. Um, this is for this state. The other three states which we see, if we are in 0 1, 0 1, you are remaining there, 0 0 state remain there. 0 1 for the second state also you remain in 0 1. The third state, if you see 0 1, you are not remaining there. Where are you going? You are going to 0 0. So that is important, right? So this is important. This has changed, right, from the top. This is 0 1 now, and that is where your y is also turning 1, right? So other cases this is 0, but in that case it turns 1. Okay. Now let's look at the other cases. Other cases are now 1 1 1 1, which is what we are looking at. 1 1 means uh, when your 1 0 is what we are looking at for the input combination X and P, and 0 0 is your initial state. 1 0, oh, you are going into the next state. Yes. So when your 1 0 is there, you are going to 0 1, right? If you are in 0 1 state, right? If your 1 0 comes, you're going to 1 0 state. Okay. If you are in 1 0 state and this 1 0 comes, where are you going? You is remaining in that state. Okay. Right. If 1 1 is coming, 1 1 is obviously invalid. So XX. Then there is a 0 0 state. Now this is for the last bit when you have 1 1 as input. And we know that for 1 1 is an invalid input, it would never happen. So for all of these are XX, right? Okay. So then one and the y is only becoming one when you are in that state, and this is what it was, right? And then for other cases, you see, yeah, we didn't write, but this would remain zero, right? For 1 0, I think input you are, yeah, you are y is zero, yes, y is zero for 1 0. For 1 1 state, y is also not defined, right? So because so then this is XX. Okay. So yeah, sorry, this 1 1, I think this would be X also, right? So then you now see that we have three outputs and four inputs, right? These are my inputs and these are the outputs which you have D1. So you have to now the next step would be to make a Carnot map for your because these are four input Carnot map, 16 entries. So you have to make a K map for your D1, your D0, and Y, right? And this is as a function of that X, P, Q1, and Q0. So this is what we can do next, and then figure out what is the logic for required for this. Okay, so then we can make these Carnot map. That's what we were talking about, right? So if you see your D1, D0, and Y, three Carnot map you have to make, right? For um, so which is, let's say, X and P, right? So you can put XP here and Q1, Q0 here, and this you are making for D0, right? So let's see which midterms we have to put for D0. 0 0 1 0 0 0, right? 1 0. So let's say 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. First is 0 0 1 0 0 0 1 0. Okay. Next is X 0 0 1 1 0 0 1 1. Sorry, 0 0 1 1. Right? And then 0 0 1 1 ho gaya. Then we have what else is 1 0 0 1 1 0 0 1, right? This is one. Sorry, which one was it? Yeah, this was 1 0 0 1 1 0 1 0. This is this one. Then we have others which are X X X X X, which are 1 0 1. So 1 0 1 1 is X. So these are all, I think 1 1 would be always X, right? This is what we saw should be. Let me just check again. 0 1 was also XC. Here we missed it, right? So 0 1 was also X, and 1 1 1 1 will also be X. So this is anyway there. And 1 0 1 1 we have already marked X. Then 1 1, all the 1 1 will be X, right? These are 1 1 where Q0, sorry, yeah, X and P are because they cannot be 1. So this is what you see in the end. You have a state table like this, where you see this is definitely one quad, you see, right? Other, this is one thing, so you could make a quad of this here, but this is not one here. Let's just check 0110. What is the status of 0110? Yeah, that is 0110, right? Okay, so then we see that this can be another uh, quad, right? Quad is much better than pair, and then you will have anyway one pair you have to make, right, with this, because this cannot come in a quad, right? Or can it come in a quad? Yes, it can come in a quad. So then we can just do this quad rather than that quad. Okay, so XX, yeah, X1. So we know this is going to be XXX1, right? So then we know that this is one quad which was there, and the other quad is this, right? So this quad, one can write D0 expression also. So D0, this quad, we see what is not changing, which is your X is not changing, right? And so X from here, and what is not changing between these two is Q0. So X Q0 plus, and here we see which is not changing in these two are 0. So 0 means P bar, right? And in these two, which is not changing, is your Q1. Right? So this is your D0. Similar to that, you can also make for D, sorry, this is what you made for D1, right? This is for D1. So similar to that, you can make it for D0. Similar to that, you can make for Y, right? That is what one can do. I'll pause and do it here so you don't have to watch me doing it again. Okay, so we see these relations out of this Carnot map, right? And then one can implement this, as we saw that there were two flip-flops one would need, right? To do that. So this is, let's say, D1, Q1, Q0. Let me just copy these relations, which we got, right? And then we have our uh, uh, the other flip-flop, which is your D0, right? Q1, so Q0, Q0, right? This is our flip-flops. Clock is connected together, right? Both are clocked same time. Now, what we need to see is what is D1. D1 is obviously a combination of first two inputs. So the two inputs which are there, one is the X and P, right? These are the two inputs which are available for user. This is the P bar of the, so X is basically going in addition to this. So we see, yeah, rather than making the connections, you can see that already one can see this. They are two going together, which is your AND gate. And with the AND gate, then you have summation with Q1 bar. So there's a P which is coming, which is this. And other than that P bar, you have Q1, which also comes as one of the input of this. And then these two will uh, have the OR, and that would go into D1. Right? So this is what is the implementation of this part of the D1. Similarly, you can do for D0. D0 would be X bar and all those things which you have to take in, right? So this is D0. D0 circuit would be something like this. I'm just drawing separately. Where you have X, you will put an inverter with this, then you will take it with Q bar, right? So Q is coming again, Q naught into this circuit, which is your AND of this, and then you have another circuit where you have X coming in, right? And then probably you have, let's say, Q0 bar coming in directly, and then you have another Q1 bar coming in. And this I'm just drawing with the two input gates. And this would give you D naught, right? And Q1 bar, Q0 are available, obviously, there. Right, so all of that, it can be also, and the Y is simple, it's just Q1 into P, right? So Q1 into P is the Y circuit you will have for AND gate with Q1. Okay, so that is what is your state machine you have built and which can dispense chai now without spilling, right? That is what you have built using this technique which we have talked today. And I think I hope you can practice that because that would help you understand how to realize this state diagrams or state tables using these flip-flops and the combination gates, right, which we have seen. Okay, thank you.